Chapter 7, Lesson 4 is simplifying radicals. Now, what we need to know is that radicals means roots, like square roots, cube roots, fourth roots, roots. So sometimes when you do roots in your calculator, you will get decimals, and we don't want that. So what we're going to try to do is use our multiplication to break up numbers into perfect squares and prime numbers. So the first 10 numbers we know the square roots of is 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and all the way up to 10 squared, which is 100. And actually in the past we've noticed we need to use 11, 12, 13, 14, and 15 with this book. Okay, so go ahead and pause here on how to do the simplifying of square roots. Okay, so most of the time when we try to simplify square roots that aren't perfect whole numbers, the two numbers that we break it up to is a perfect square and a prime. So when I try typing the square root of 28 into my calculator, I get a decimal of 5.3. And we don't want to use decimals, so we want to try to break 28 up into a perfect square and a prime. Well, looking at my perfect squares, I know that 4 times 7 would be a perfect square times a prime. And so then I asked myself, okay, can I break that up? Yes, I can break it up into square root of 4 times the square root of 7. And I know the square root of 4 is 2, and I know that 7 is a prime, and so it has to stay under the square root. Now on number 2, 40, I try to break it up. 40 would fall right here on my number line. It does not divide by 36 evenly, nor 25, nor 16, nor 9. So 40 breaks up into 4 and 10. The square root of 4 is 2, and the square root of 10 cannot be done, and so we leave it as 2 square root of 10. Okay, now on this next one, it started out as a broken up square root, but we can't break up 2 or 10 with our square root numbers that we have. So what we're first going to do is combine them back into one square root, which is 20, and then try to break that up into a perfect square and a prime, which is 4 and 5. So that would give me 2 square root of 5. Same thing with number 4. 5 times 60 is 300. And now looking at all of these perfect squares, 300 does not break into 225 or 196, 169, 144, 121 evenly. It does, however, break into 100 times 3. So I'm going to rewrite that as 3 times 100. And the 100 comes out to be 10, and the square root of 3 cannot be done. And so the answer would be 10 square root of 3. On this one, the only like terms I'm going to combine are the 3 and 15 for the square root of 45 underneath. Then I'll multiply these ones on the outside like terms, which would give me 6. Now 45 breaks up into 9 and 5. And the square root of 9 is 3. And so then my final answer would be 18 square root of 5. Okay, the next one is 68 divided by, I know it's not going to be 64, 69, or 49 does not break up. 36 does not go in there evenly. 25, 16, 4, 9. So actually, the only thing that breaks up is 4 times 17. So this one becomes 2 square root of 17. On this one, the first thing we want to do with fractions is to reduce them. So when I reduce this, I will actually get the square root of 1 over the square root of 2. Come on. And the only one I can do is the square root of 1 is 1, and the square root of 2 does not change. On this one, I'm going to reduce the whole numbers and also reduce the roots. So 2 over 8 reduces to 1 over 4th with my square roots, and 8 over 2 is 4 over 1. And I can actually take the square root of everything here. And my final answer then by simplification would be 2. The next one, 3 times 6 would become 18, which breaks up into square root of 9 times square root of 2, which is 3 square root of 2. So once we've broken them up into their most simplified radical, we can add or subtract them. But we can only add or subtract like roots. So on this one, I have 7 square root of 7s minus 2 square root of 7. And so when I'm adding or subtracting, just kind of like my x's, if I had 7x minus 2x, I would just say 5x. And so I'm treating these square roots kind of as variables. So if I have 7 square root of 7s, take away 2 square root of 7s, I'd have 5 square root of 7s left. This one I have 3 square root of 13s plus 7 square root of 13s, so I have 10 square root of 13s. 9 square root of r's minus 12 square root of r's is 3 square root of r's. And now when we get down to this one, notice that we have 2 sets of like terms here. And so I have 2 square root of 13s minus 5 square root of 13s is negative 3 square root of 13s. And 4 square root of 2s plus 1 square root of 2s is 5 square root of 2s. Now, on number 19, I noticed that, first of all, they're not like variables or radicals, and also they can all be broken down. So I can really write 8 as square root of 4 square root of 2, and I can write 20 as square root of 4 square root of 5, and I can write another square root of 8 as square root of 4 square root of 2. So by breaking them down first, this would come out to be 2. So I'd have 10 square root of 2. And over here, I would have minus 2 square root of 2. And this would come out as a 2, so I'd have plus 4 square root of 5. Then combine like terms, 8 square root of 2 plus 4 square root of 5. Okay, so following along with this bottom one here, the square root of 27 is square root of 9 square root of 3. Square root of 18 is square root of 9 square root of 2. And 100 is 103. So this one becomes 3 square root of 3. This one becomes 10 square root of 3. And this one becomes 3 square root of 2. Then combine like terms, I have 13 square root of 3s plus 3 square root of 2s. Same on this one. This would become 5 square root of 4 square root of 2 plus 3 square root of 4 square root of 5 minus square root of 16 square root of 2. So this 4 comes out to be a 2 and gets multiplied by 5, so that's 10 square root of 2s. This 4 comes out as a 2 and gets multiplied by 3, so that'd be 6 square root of 5s. And this comes out as negative 4 square root of 2. Combine like terms gives me 6 square root of 2s plus 6 square root of 5s. So remember we talked about in 7.2 or 3 that the square root and the exponent of 1/2 are the same thing. So whenever we try to do variables, we're going to put them to the 1/2 power. So when I do 81, I'm going to say square root of 81, And then I'm going to put a squared to the 1/2 power and d4 to the 1/2 power. Now the square root of 81, I don't have to break up because it's just 9. And then I distribute here would become a to the first, and distribute here would become d to the second. On number 840, I am going to have to break up into square root of 4, square root of 10. And then x to the 4th to the 1/2 power, y to the 6th to the 1/2 power. So I'm going to have 2 square root of 10, x squared, y 3. On number 6, the square root of 16, I don't have to break up. That is 4. And b to the 4th to the 1/2 power is b squared. Okay, now, so far we've had all even exponents. Well, what happens when it's an odd exponent that we can't take half of? So that one is also going to get broken up. So first of all, starting with 56, I think 16. Nope. It's 4 and 14. And then we can do m squared to the 1/2 because that's an even, and 4 to the 1/2. And then we're only going to bring out p4 to the 1/2, and we're going to leave p1 underneath the square root since we can't take half of it. So notice that if I have 4 here and 1 here, that gives me my total of 5. It's just broken up. So that would give me 2 square root of 14, and I know the p is going to be under there too. Then I have m1, n2, p2. When a sky jumper jumps from an airplane, the time it takes to fall a given distance can be estimated by t equals square root of 2 times s divided by 9.8. If Julie jumps from an airplane, how long will it take her to free fall 750 meters? So we know s is our meters, so we're going to do the square root of 2 times 750 divided by 9.8. And we get 12.3 seconds. The speed in sound in meters per second near Earth's surface is given by that equation. What is the speed of sound at 15 degrees temperature and 2 in simplest form, which means no decimals? So if I did 20 square root of 15 plus 273, that would give me 20 square root of 288. Trying to find out what it breaks up into. Okay, so 288, I should have known, is square root of 144 square root of 2. So the 144 would come out to be 12, and 12 times 20 is 240 square root of 2. Then we have to do 2 plus 273, which is 275. And it took me all the way until 25 times 11. And so the 25 would come out to be 5. Multiply that by 20, we get 100 square root of 11.